Unit 2, Introduction to Networking and Topologies. The first part is called as Overview of Networking. When two devices want to communicate, which involves four components actually: the sender, which is sending the information, the receiver, who is receiving the information, and a language, also called as protocol, and medium through which the communication is established. When two or more computers want to communicate with each other, the computer want to agree upon certain protocols. Unit 2, Introduction to Networking. Unit 2, Introduction to Networking and Topologies. The first part is called as Overview of Networking. When two devices want to communicate, which involves four components actually: the sender, which is sending the information, the receiver, who is receiving the information, and a language, also called as protocol, and medium through which the communication is established. When two or more computers want to communicate with each other, the computer want to agree upon certain protocols. That means protocol is actually nothing but a software which tells how two computers, or when two computers want to communicate with each other. It's some type of regulations or guidelines given to both computers. To transmit data from one computer to another computer, there may be need of some medium. The medium may be in the form of cable or wire, or maybe some wireless. In cable we are using some twisted pair, coaxial cables and optical fibers, like that. In wireless technology we are using satellites, microwaves, infrared and broadcast radio. Such mediums are used for data communication. The main purpose of networking is the resource sharing of printers, hard disk, files, software, etc. by a multiple computers. Instead of putting a separate printer on each workstation, we can connect a single printer by a number of computers and share it. That is the main purpose of actually the networking. The next one is called as need for networking. There are many needs are there. In that one, first one is speed, resource sharing, communication facilities, and backup and failover. The first one is called as speed. What is the meaning of speed? When the main purpose of networking is speed, you can quickly access files and other resources available in the network as quick, very quickly. Just imagine you are having some files in another computers and you want to use that file in your computer. If there is no network in there, first you have to copy that file in your pen drive, and you have to bring that pen drive to your computer, attach it to your computers, and then access it. If the distance of the traveling is far away, then the speed is very slow. But if you are having a network, within a fraction of seconds you can quickly access that file. The second one is called as resource sharing. Resource means actually the hardware as well as software parts available in the computers. Now imagine if you have a very costly software and you want to install that software on every machines. It is more expensive. So through networking, what we can do, we can install the software in one machine and share that software in number of hundreds of machines. That may reduce the cost of the software. At the same time, attaching a printer to every computers in office. If you have hundreds of computers and you have to attach hundreds of printers, it's a very costly. So instead of that one, we can install or connect one printer to a one machine, and we can share that by using a networking technique. Like that, many hardware resources like fax machines, email servers, web servers, file servers and scanners can be shared. The third need for the networking is communication facilities. In today's world, communication is one of the important requirements. Now we are sending some mail by using computer in the form of email messages. We can send it to anywhere in the world within a fraction of seconds. In past, we are using some postal service for mail messages, which is a time consuming process. Now apart from email, we can also communicate with others by using some chatting, video conferencing, teleconferencing, etc. Means the communication facilities drastically increase with the use of networking. The next one is called as backup and failure over. When you are having a computer, the computer contains hardware parts. It's common to the hardware may be failure occurs. It's a common in computers. The failure may occurs. Your hard disk may crash, your computer may crash, something happens. So it's a good practice to take a backup. One technique is take a backup in your secondary devices, external devices. Another good technique is called as backup using network. We can backup multiple computer information with the help of a network. So backup is the one more need for networking. Next one is called as hardware components. Some of the hardware components which is used in computer networks are cables, network interface card, which is also called as NIC. Next one is repeater. Next one is hub, switches, routers, gateways and bridges. The first one is called as cables. Cables are commonly used medium for transmitting data over a network. If I want to transmit some data, we generally use cables. The most commonly used cables are coaxial cables, twisted pair cables, optical fibers. In today's, coaxial cable is used very less. The next component is network interface card, also called as NIC. The NIC or the network interface card is a hardware device that acts as an interface between your computer and a network. This device actually converts your data into electrical or optical signals. At the receiving side, it just converts your signal into data and transmit to the computers. In olden days, the desktop computers actually contain NIC as a expansion card. This diagram, okay, it looks like it is a expansion card. We are just attaching this expansion card directly on your motherboard, and here we are connecting a RJ connector port, which is a backside of the your backside panel of the computers. And today's computers as well as laptops, these network interface card is on a chip or a IC, which is directly embedded on a motherboard. The next component is actually repeater. Hardware device is a repeater. In last class I told about attenuation impairment. In attenuation impairment means whenever you send some signals over a medium, its energy is continuously decreasing. For that one we are using amplifiers. Here this repeater is also an amplifier. It will just take a signal from the input and generates a new copy of that one. Instead of amplifying, it will completely create a new copy of that input signal, which is amplified signal, and send it to the destination. So repeaters generally contains two ports. One is for input and one is for output. The next device is actually called as hubs. These are also a repeaters, but which contain multiple ports. These are actually connecting multiple segments of same network and transfer data from one segment to another. If you want to create a LAN, we are generally using hub, where we can connect, where this hub provides multiple ports, 5 to 10 ports. We just connect computers, printers, scanners, routers, other devices to directly this port. Okay, this hubs has some disadvantage also. It is having no intelligence. So whatever the data it will send, it don't know in which computer it has to send. Okay, from which port it has to send, it don't know. So what actually it will do, hubs, it will just broadcast. For example, if this A computer wants to transmit some data to C, computer C, what actually it will do, it will just transmit that data to the port here. Okay, it just broadcast this data to all the other devices. It will send it to B, it will send it to C, it will send it to D. Due to which the network traffic will be increased here. Instead of sending just C device, it will send it to all the other devices. So the network traffic increase. This is the first disadvantage. The second one is all the other devices also get this data. So network security problem may also arises. There is a possibility of collision of data is also increased. For example, this computer also transmit, this computer is also transmit at the same time. here there is a possibility of collision. So in today's world, hubs are very rarely used. If you have very small number of computers, 4 to 5 computers, then we can use hubs, because hubs are little bit less expensive than other devices. Next one is called as switches. Okay, one more advantage of this one is hub act like a central point. It act like a central point. Means many different computers or devices are connected to these hubs. Generally, it is used in the star topology. I will explain that one in the next class. Star topology. And switches also work like a central point for various devices. Just like hub, it is also a central point for various devices like computers, printers, and routers. But these switches are little bit more intelligent than hubs. This switch reduces the network traffic and improve the network performance. Okay, how actually it will do? Instead of sending the data to each and every device, it will send the data to only that device which it is mentioned. For example, if this node A want to send some data to node C, so what happens here? It send the data. Node A send the data in the form of data frame. So data frame contains an additional information called as MAC address. This MAC address is available in each and every machine. Each and every machine has its own unique MAC address. MAC address is also called as physical address of the computer, which is stored in the hardware part of the computer, that is NIC. Okay, whenever it sends the data in the form of data frame, this switch read that MAC address. This switch already maintain a table of this MAC address. Which computer is connected to which computer is connected to which port? It is already here. So whenever we read the MAC address, it knows that this MAC address data is for this computer. So it will just send the data directly over this port. It never broadcast. It just sent the data to this port. So due to which the network traffic is decreased. These devices generally work on layer 2 of the OSI model. Hubs and repeaters works on the layer 1 model, layer 1 of the OSI model, whereas it works on the layer 2 of the OSI model, which is little bit more intelligent than hubs and repeaters. Next device is called as routers. Routers are devices that uses the network address for filtering and forwarding information to different networks. In past, I am explaining about some of the devices like repeaters, hubs, switches. These devices are actually used for connecting local area networks, a single network. But routers are actually used for connecting your computer to the another computer which is located in far away, not within your network. Okay, what is the job actually here? The job of the router is actually filtering and forwarding. When you are connecting a computer in a local area network, the MAC address is sufficient to transmit the data. But when you are connecting your device to the network in other side, means another network outside, the MAC address is not sufficient. We need a address called as IP address. We need address called as IP address. Whenever this device A wants to transmit some data, okay, whenever this node A want to transmit some data to node C, it will send one packet. Okay, here it is sending a one packet to all the devices. It will send it to B, it will send it to C, it will send it to router 1. Okay, this packet contains IP address of node C, so it will just accept it here. Okay, here it contains the IP address of this node C, it will just recognize it and then accept it. Here it will reject it. Router also contains or received that packet. It will check for the IP address. Router is the no. It is maintaining one table called as routing table. This routing table contains the IP address of different devices connected in the local as well as far away. Okay, now it understood that it is more intelligent than the other devices, the past devices. So it understood that IP address is for local machine. So it will never send that packet to the outside. Never send that packet to the outside. So this is called as filtering. Now, if the node A want to send data to the node D, it will send that packet with the IP address of node D. Here the IP address is stored as node D. So all the other devices accept this packet but reject it. Whenever router got this same packet, it understood that this packet is not for local machine. So it will forward that to the another router. This router already maintains some path. Router is the no, it also contains some information on the path. It also maintains some path. If I want to send data to node D, which router I have to pass? So this router already know. So it is sent it to the router 2. There may be some other routers are also available in between. There are so many different routers are there in between, but this router 1 transmit to the router 2 because it already know if the packet is sent here, it is reached to the destination. So it will send it to router 2, and router 2 knows that node is available here, node D is available here, so packet is sent here. So this is the work of routers. Routers maintain routing table. Its work is filtering and forwarding, and this is called as forwarding. Whenever you send the packet over a other network, it is called as forwarding. It is also maintaining the path of the destinations. For that one, it has to follow some rules. For filtering and forwarding, it has to follow some rules. The rules is already mentioned here. Next device is called as gateways. Gateways are actually devices or a service that translate communication protocols and enables two similar or dissimilar LANs such as Ethernet and token ring to communicate with each other. Okay, it's one more type of device. Okay, what happens if there are two networks are there, they are having different protocols. Then you have to send some data from this computer to this computers. The protocol conversation should be done. For example, if somebody knows English and another person knows German or Japanese, then they cannot communicate with each other. There are some intermediate persons or some devices needed which will convert the language English to German or German to English. The protocol conversion, such protocol conversion is done by gateways. Gateways are generally connecting two dissimilar type of LANs or two dissimilar networks which is having different protocols. For example, here a TCP/IP network is there, but here IPX SPX network is there. Both are maintaining its own set of protocols. If they want to communicate in between, they are using gateways. Gateways are actually, here as it told, so it's a combination of hardware. Unit 2, Introduction to Networking and Topologies. The first part is called as Overview of Networking. When two devices want to communicate, which involves, the first one is called, so it's a combination of hardware and software. Gateways are generally hardware and software, and this gateway is actually working on the application layer of the OSI model. That is the topmost layer of the OSI model. So it is containing more and more feature, okay, more and more powerful than other devices. Next device is called as bridges. A bridge is a device that filters and forwards traffic between two or more networks. Here, bridges connect two networks that use different layer 2 protocols and translate data between them. Okay, now this is an example of bridge. Now what happens? This bridge segment the large network into small networks. In office, if you have many computers, hundreds of computers, network traffic goes on increase and your network performance decrease. So the networks are segmented to number of small networks. That can be done by bridge. Here the bridge, what actually it will do, if the computer want to send some information to the other computers, this bridge will just check whether it is belonging to local computer or the next segment of the computer. Okay, depending on that one, it will just. Unit 2, Introduction to Networking and Topologies. The first part is called as overview of networking. When two devices want to communicate, which next device is called as bridges. A bridge is a device that filters and forwards traffic between two or more networks. Here, bridges connect two networks that use different layer 2 protocols and translate data between them. Okay, now this is an example of bridge. Now what happens? This bridge segment the large network into small networks. In office, if you have many computers, hundreds of computers, network traffic goes on increase and your network performance decrease. So the networks are segmented to number of small networks. That can be done by bridge. Here the bridge, what actually it will do, if the computer want to send some information to the other computers, this bridge will just check whether it is belonging to local computer or the next segment of the computer. Okay, depending on that one, it will just filter or forward the packets. It also works on layer 2 of the OSI model. So the filtering is done on the local area network basis. Okay, sometimes these bridges are also connected to dissimilar type of networks. That is, on layer 2 the protocols are different one. So bridges are also used for segmentation to reduce the network size into smaller groups.